This lighting can perfectly wake you up during a night walk to the toilet. A dimmer light for nighttime trips would definitely be better than the sun. We try to solve that with these little lanterns. They had the advantage of a significantly lower luminosity and automatic turning on with a motion sensor. Their disadvantage, however, was the need for fairly frequently battery changes. So I decided to make a few changes which I will show you in this video. Everything you will see in this video is done by a person who has absolutely no idea what he is doing. Don't try to follow my steps. Everything you do at your own risk. My aim was to get similar night lighting to what we already had. I just wanted to get rid of the need to replace the batteries and better solve its placement. My original thought was to lower the intensity of the overhead lights, but that modification would have been more challenging than I liked. So I decided to reach for the white LEDs, which are less bright and can be nicely hidden in the ceiling. I mean, they can be hidden, but you have to give them a little help. I drew a socket like this one in the Onshape program. Then I printed it out of a regular white PLA on a Prusa Mini 3D printer. When creating this lighting, I was thinking about making it as easy to service as possible. That's why I decided to use ordinary DuPont connectors instead of soldering the wires directly to the LED. Since I already had the light more or less figured out, it was time to figure out the placement of the LED lamps themselves and how to lead the wires to them. For some holes the wiring was easier. For others, it was rather complicated. Since even a master carpenter sometimes makes mistakes, I could not be an exception. Fortunately, a little bit of plaster and not completely clumsy hands can do wonders. All that was missing was a light touch of white paint. The first control light up was successful, so I moved on to the last step of the first phase. This was to slide the bulb sockets onto the bulbs and into the ceiling. The first version of this lighting was controlled by a smart socket and scheduled switching times at night, which turned out to be totally impractical. I had all the bulbs wired in parallel, so I didn't have to deal with calculating the voltage to the number of LEDs. To power this lighting, I used a regular 5V USB charger and an adjustable voltage regulator. I eventually reduced the voltage down to 2.9V, which proved to be perfectly sufficient at night and did not risk damaging the LED bulbs. The only thing missing to perfection was automatic switching on when needed. And since my motto is that even the impossible is possible, I set out to solve this problem. To accomplish that, I bought this motion sensor. Besides the fact that it was a model that could be beautifully placed in the ceiling, it had another advantage. That was actually the way it works. This sensor is powered directly from the mains, and when motion is detected, it passes the input voltage through the output connector. Basically, it's like a regular push-button switch you have at home, except that it's triggered by the presence of heat. To make the job as easy as possible, I decided to use a 7-meter long extension cord, 2 and 3-pin Wago terminals, and a plastic box already prepared for the installation of the electronics. Yes, I know, I could have printed out, but it was Christmas time and I was lazy as a pig. My plan was to make a motion sensor switched socket. All I had to do was remove the plug and socket from the extension cord, make holes in the box for these cables and put the cables in them. In the case of a single sensor, it would only be necessary to make one hole on the opposite side of the box. I would plug the remaining part of the extension cable into this hole and attach the other end to the motion sensor. Then it was time to remove the insulation from the individual wires and plug them into the Wago terminals. The wall wiring was actually very simple. I connected the blue 0 wires together. I also connected the protective yellow-green from the socket and plug together. I connected the brown phase wire to the brown sensor power wire. Now the only thing missing was the connection of the sensor output to the brown phase wire of the socket. Since the only free wire was the protective yellow-green one, I decided to recolor it black. What you just saw was a serious violation of the wire marking norm. It says that a protective conductor marked in yellow-green shall not be remarked or used for any other purpose. Please take this into consideration and don't try to follow my steps. Everything you do at your own risk. Then I connected the remarked wire to the brown phase wire of the socket. Finally, all that was needed was to lock the wires in the box and proceed to install the box in the ceiling. Here is an example of the wiring to the motion sensor. And yes, I did remark the protective yellow-green wire here as well. Before I moved on to installing the lighting in the ceiling, I tested to make sure everything was working as it should. Due to the need for two motion sensors, I connected the second sensor in parallel to the first one. This allows the light to turn on when motion is detected by either sensor and turn off according to the sensor that last detected motion. During the installation, I tried to find the most suitable place to place the sensor. I wanted to place the sensor in the middle of the corridor, but I had to adapt to the construction of the ceiling. When creating the hole to place the sensor, I needed to avoid the structure and cables I already had in the ceiling. Then, I needed to route the cables to the sensors and plug the sensors into the ceiling. Finally, I just plugged the USB charger that powered the lighting into this motion sensor controlled extension cord and it was done. A job for a couple of hours and, at least from my point of view, the result is worth it.